All right, so I did touch on this in our review of multiplication and division, or multiplication video. Um, but our focus today is going to continue to be developing an understanding of operations, helps us to solve problems in the real world. And remember, operations includes multiplication, division, adding, and subtracting. Our specific concept today is to demonstrate an understanding of estimating for products and quotients with decimals. So again, no calculator for this unit. You may use a multiplication table if needed. No calculator is allowed, and I do expect to see work. Otherwise, I will assume a calculator has been used and you will be asked to redo. So make sure that there is work with your multiplication and division. With estimation, work is not as necessary because it's based on your basic facts for the most part. All right, so this is in your unit. It's Unit 3, Lesson 2. Let's take a look at our problem here. A ping pong ball has a mass of 2.73 grams, or 2 73 hundredths of a gram. We want to estimate then the mass of 8 ping pong balls. If this is how much one weighs, how much will 8 of them be? So we would have to multiply 2.73 or 2 73 hundredths times 8. To estimate, she used front-end estimation, and front-end estimation is not any different as it was before when we were adding and subtracting. We use the place value of the front digits of a number, so I'm going to make 2.73 or 2 73 hundredths into 2. 2 times 8 is 16. So 16 is very close to what our answer would be. And in fact, if I were to do the work for that one, I could see that 2.73 times 8 in my calculator here is actually 21.84. So if I were just doing straight multiplication and I needed to use estimation to place my decimal, and this is the number I got in my calculator, what's close to 16? Well, 21 is close to 16, so my decimal could go there. Sometimes we use estimation to help place our decimal as well, not only to check whether or not our answer is close. So that would be an example of front-end estimation with decimal numbers. Let's take a look at another strategy. Here we have Hal, who's decided to use decimal benchmarks, or benchmarks, which is really not any different than benchmarks from adding and subtracting. Since 2.73 is closer to 3, and we can use our good old rounding rule. If we have 2.73 and I want to make it a whole number, I'm going to have my 2 look at my 7. Remember, our rounding rule is we look right next door, which is the 7. If it's 4 or less, we just ignore. If it's 5 or more, we add one more. So we're going to have to add one more, which means it's going to have to become 3. And remember, everything after it becomes 0, so it just is 3. 3 times 8 then is 24, which again is very close to 21. All right, let's continue here. Now we have 4 baseballs that have a total mass of 575 and 94 hundredths of a gram. So that's for 4 baseballs. Okay, so make sure we realize that 4 baseballs have a total mass, so all together they weigh this much. We want the estimate of one of them. So if 4 of them are this much, how much is 1? Well, that means we're taking this number and putting it into 4 separate but equal groups. So that means we must divide. 575.94 divided by 4. Front-end estimation is another strategy we can use. 575 and 94 hundredths then becomes 500. 500 divided by 4 is not too hard. 4 times 100 would be 400, and then we'd have 100 left over, which we would divide 4 times is 25 equally, so 125. The other option that we can use is compatible numbers. So we've got front end and we've got compatible numbers. Compatible numbers are numbers that are easy to use mentally. Mentally is in your head. So you want this to be numbers that you can do in your head, or if you need to, use your multiplication table to assist you thinking about our annexing zero rule. But an estimation should be something that you are able to do in your head. So there should not necessarily have to be work in this case. Okay? All right, so if we were going to use compatible numbers, well, 575 is closer to 6, and 6 divided by 4, again, 6 divided by 4, well, 100 times 4 is 400, so that would be the 100 part, which would leave us with 200 left over. Well, 200 divided equally between 4 groups would be 50 each, so 150 would be our estimate. Remember here we've made our mass larger, so this would be an overestimate. In this case we made our mass smaller, so that would make this an underestimate. All right, now you're going to practice. I'd like you to try to estimate A and B using using compatible numbers for both of those, or benchmarks, either one, they're kind of similar. For A and B, and for C and D we're going to use front end estimation for each of those. These are just multiplication at this point, so try both of those. Alright, so let's take a look, and I'm just going to write things down because it's nice to have a visual. You don't necessarily need to be doing much writing other than the numbers that you've made them into. So if I was using compatible numbers for A and B, or benchmarks, well, 4 would stay 4. And 59 cents would be pretty close to $1 or 1, so be close to 4. 1 times 4 would be 4. For B, we have 6 times 2.3. Well, 2.3 or 2 3/10 is really close to 2, so I'm just going to go 6 times 2, which is 12. C and D, we were using front end, so C would be 3 times, and we have 2.175 or 2 175 thousandths. I'm just going to use the 2, I'm dropping the rest. 3 times 2 is 6. D, we have 7 times 11.8, and again I'm just using front end, so 11 8/10 just becomes 11. Well, 7 times 1 is 7, 7 times 1 is 7, so 7 times 11 is 77. Those would be our estimates for our multiplication. All right, now you're going to estimate for division. Front-end rounding is always an option. I find compatible numbers works generally a little bit better because I turn the number into one that can actually be divided equally without a decimal. So I would probably use compatible numbers for A and C. Go ahead and press pause and try compatible numbers for both of those, and do think of what can they actually truly be divided by, and change them into a number that they can actually be divided by. Right, so if I have 21.8 divided by 5, make that division sign just a little bit clearer, or make it worse. Sorry, iPad pens just really are not quite as exact. If I'm thinking of something that is close to 21 8/10 that can be divided by 5, well, 5 times 25 or 5 times 4 is 20. I'm going to go with 20. 20 is closer, so 20 divided by 5. Well, I know then it has to be 4, so if this were my answer, 436, I know my decimal would have to be 4.36 or 4 36 because that estimate helped me place that decimal. That was for A. Now for C, we have 13 23 divided by 9. Well, 13, so let's check. 9 times 2 is 18, that's pretty big. 9 times 1 is 9. Well, I'm going to go with 9 because that's closer. So 9 divided by 9 equals 1. So if I'm trying to place my decimal, if I have 147. Well, closest to 1 then would be 1 and 4700. So that's where my decimal would have to be placed. So sometimes estimation can also be used to place the decimal into an answer. All right, estimating again. Now 2 more with division. All right, 2 more for division. As you notice, I actually did change the second question. I really don't love it, so we're not going to do that one. We're going to estimate for both of these, and you can choose to use front end or compatible numbers. You go ahead and pick whichever you prefer. All right, so let's take a look at A. 1.8 is or 1 and 8/10 is very close to 2. So 2 divided by 2 is 1. So my answer is going to be near 1. C, 47 and 65/100 divided by 7. Well, I'm going to look for a number that's close to 47 that can be divided by 7. 7 times 7 is 49. That's pretty close. So let's make it 49 divided by 7, which would make it 7. So I know my answer is going to end up being close to 7. And as you can see, compatible numbers works a little bit better than front end. Let's try that last one if it were front end estimation. Oops, sorry, I need my pen. That would be 47 divided by 7. Well, I don't know about you, but I can't do that part in my head because it would end up being some sort of a decimal number. So in this case, front end rounding really doesn't work. So you have to be really careful about when it is that you choose to use front end rounding. So for example, if I had 20.56 divided by 4, then front end rounding works quite well because I know that 20 can actually be divided by 4. But if that's not the case, it makes it really tricky to use front end estimation. So I actually wouldn't recommend using front end estimation in most cases. Compatible numbers really for division is your best bet because then at least you can get numbers that can truly be divided. All right, at this point you're moving on to your concept practice, and you are practicing estimating with products, which is multiplying, and quotients, which are division, and all of them will have decimal numbers. So estimating with multiplying decimal numbers and estimating with dividing decimal numbers. Remember, this allows you to practice the skill. It will become homework. We will mark and discuss it. Make sure that you are showing all of your work. Any calculator is not an option. You may only use a multiplication table. We are working on page 94 of Math Makes Sense, grade 6, numbers 1, 2, 3, 6, and 7, making sure you show your work. All right, after we have marked the concept practice, you will be moving on to the exit slip. The exit slip is here for you electronically if your paper version has been misplaced. As always, make sure you're showing your work. Exit slip, remember, is a check to see how you're understanding the concept so far. Must be handed in so I can see how it's going. This concept we are working on was 2-digit multiplication and estimating for products and quotients with decimal numbers. So 2-digit multiplication, estimating with products multiplying, and quotients dividing with decimal numbers. Show your work. You may use a multiplication table, you may not use a calculator. So if you've misplaced your exit slip, here's your exit slip for you. Go ahead and do that.